Hi guys, this is Shiva Reddy. In this session, I am going to explain Java interview questions on Java multi-threading. So this is one of the important concepts for the interview perspective. So I'm going to explain most frequently asked interview questions on the Java multi-threading. So let us go ahead and start. What is meant by a thread and what is a process? So a process is a self-contained execution environment. That means whenever you create a process, the CPU is going to allocate a separate memory allocation, and as many process you are going to create, those many memory allocations will be done at the CPU level. So thread is going to be heavy weight because it has going to consume the lot of resources like a CPU resources and updating in registries, and also the communication between the one process to another process, it is going to be very high because it needs to be updated the memories registers, and switching between the one context to another context is going to be very high. But in the case of thread is a lightweight component and also a subunit of the process, and has its own path of a separate path of the execution. And whenever you create a thread, so it is going to use the shared memory locations, and that means at least a process contains at least one thread. So when you create a multiple threads in a multiple threads, then what happens is within the single process, it is going to allocate the multiple threads, and those threads are going to use the shared memory location. Hence, by using the threads, you can utilize the memory efficiently. And second one is the cost of communication between the threads is very lightweight, and third one is you are going to use the efficiently the CPU. You can utilize the CPU very efficiently. So these are the three benefits of the multi-threading. Okay. Now next question is the next question is what is multi-threading and what is multi-processing? So multi-processing is executing the multiple process simultaneously is known as a multi-processing. In the case of multiprocessing, the CPU having utilization of the CPU is very high, and resource consumption is also very high, and also the communication between the one, and also intercommunication between the one thread to one process to another process is very high because whenever it wants to switch from the one process to another process, CPU needs to save the current state of a particular process, and then it needs to update the registries, and then it needs to switch to the new process. Again, when it want to switch from the old process, then again it needs to save the current state of an process and needs to update the registries and memory, and then it needs to switch to the old process. So the cost of communication between the process is very high. But in the case of multi-threading is executing the multiple threads simultaneously is known as a multi-threading, and the cost of communication or the intercommunication between the threads is very low, and also the memory utilization you can specify in the multi-threading is very low because threads are going to use the shared memory location. So that is the by using the diagrammatic representation at a high level, you can specify like this. So whenever you create a each process like that, every time you create a each process, it is going to create a separate memory allocation. But in the case of threads are going to be inside the process and which are going to use the shared memory location. So that is what the basic difference between the multi-threading and the multi-processing. The next question is how to create a threads in Java. In Java, you can create threads in two ways. One is by extending the thread class. So for example, here I am giving a code snippet at high level. So I am creating a my thread class which is going to extend the thread class. Now you need to override the method called as a public void run method, and here you need to provide the whatever the functionality you want to achieve when the thread starts, then you need to provide the functionality in the run method. So this is the one way you can create a thread. The another way is using the extending by implementing the runnable interface. So by implementing the runnable interface, here is a code snippet. So public class my runnable, which is going to implement the runnable interface. Runnable interface having the one method, that is the run. So you need to override the run method, and here you need to provide the whatever the functionality you want to execute when the thread starts. Then you can provide in the run method. So these are the two ways you can implement you can create a threads in Java. First one is by extending the thread class. Another one is by implementing the runnable interface. Now the follow-up question comes is when to use the runnable interface and when to use the thread class, and which is better. So runnable class is always preferable because it is going to achieve the abstraction, and you want to use only the specific functionality, like only you are not going to use complete functionality of the thread class, whatever you it is comes as part of the thread class, then there is no need of actually going with the thread class. So the first way is, if you want to use the only basic functionality of the threading, then go ahead with the runnable. And second one is, if your class is already whatever the class you want to implement the thread, then if you want to if that class is already extending some other class, then it is not possible by extending the thread class, so you have to go with the runnable interface. So these are the two scenarios where you can preferable go with the runnable interface. And the next one is when to use the thread class. So if you want to utilize the thread class functional thread class behavior completely, because for example, my thread class is extending the thread class. That means my thread class will have the capability of using complete abstraction, complete functionality, whatever it is available in the thread class. If you have that scenario, then go ahead and use the thread class. And also, if you are not sure, if you are sure that your class, whatever the class you are going to, whatever the class you are going to extend the thread class is never going to use the any other classes in the other available classes, then you can use the thread class. Then the next one is, what is the life cycle of a thread? So whenever you create a thread in Java, it has different stages it will move on from during its life cycle. The first one is the new status. That means whenever you create a thread T1 equal to new thread, for example, now just now this newly born thread, but it not yet started anything. So this is called as an new status. Now you created a thread and you applied a thread dot start method. Then what happens is, the thread from the new status to it move to runnable status, but not at executed. Now what happens is, once you start it, now the thread scheduler will come into the picture, and thread scheduler, based on the CPU availability and the priority of the thread scheduler will pick up the thread and it will submit the request to the CPU. Now based on the CPU availability, the thread is going to be executed. Now the thread state changes from runnable to running. Now, if there is no other waiting or the blocking happens, then the thread will completely executed and the status will become terminated status. But while executing, if there is any IO operation happens, or sleep method you have applied, or wait method you have applied on the thread, then what happens is, from the running status to it will go to the wait or the block status. Again, whenever you sleeping, if you apply a sleep method after a particular time of sleep it has elapsed, then what happens is, again it will thread will come to the runnable status. Or the thread is waiting for the lock on a particular resource. Now it has acquired the lock, then it is again will come to the runnable status. So these are the different states are available move one when a thread is started from during its execution. So just now born thread, it will be in the new status. Whenever you start, it will come to the runnable status, and based on the thread scheduler or CPU availability, the thread will be submitted to the thread scheduler will be submit the request to the CPU. Now CPU start executing, then the status will become running. Once the thread completes its execution, then it will be terminated. In case if you are applying any wait or the sleep or IO operation happens, it will come to the waiting or the block status. Once the time is elapsed or the the thread notify on the waiting thread happens, then it will come to the runnable status. So these are the different states of different states during execution of a thread. Now, the next question is, what is the we have different methods available in the thread classes, that is sleep, yield, join, wait, notify, set priority, daemon. So what is the use of each method? So it is a permutation combination, so it is very frequent ask questions about these methods. So the first one is sleep. Sleep method is always make sure that the current thread is going to be sleep for the specified amount of time. So sleep method is going to take a parameter, that is a millisecond. How many milliseconds you are going to pass for the sleep method, that much time the thread is going to be sleep. Next, what is meant by join? Whenever you apply a join method on the particular thread, then that thread is going to be that join method is going to make sure that the thread is going to be currently wherever you applied that join method, the thread is going to be die. That means until it completes that particular thread, it will not give the chance to other CPU chance to other threads to run. So that is meant by the join. And what is meant by yield? Yield is a reverse. Whenever you apply a yield method on a particular thread, then what happens is the particular thread is going to wait for some time, and it will give the chance to other threads to execute it. If there is no thread is waiting for the CPU, then what happens is the current thread is going to be executing. Next, what is meant by wait? So wait is basically to wait method is going to wait the particular thread, and it is going to release the resource and waiting for the notify command from the another thread or the different thread. That means whenever you apply a wait method, the current thread will be in the waiting status and is going to keep on waiting until some other thread actually invoke the notify method on this resource. Okay. And next, what is meant by notify? So notify is basically to wake up the thread which is waiting for the signal on the resource. And then set priority. So you can set the priorities, that is Java we have three priorities, that is the min priority, max priority, and medium priority. By default, all the threads whenever you create, if you don't set any priority, this is going to be a medium priority. And if you want to set as a max priority, then you can use the by using the set priority, you can set as a priority. And then whenever the thread scheduler is trying to execute the threads based on the priority, it will pick up the highest priority thread and it will submit the request to the CPU for the execution. And what is meant by set daemon? Set daemon thread is going to use to set, if you want to set any thread as a daemon thread, then you can use the set daemon thread to mark that thread as a daemon thread. So these are the different methods which are frequently used in the thread classes. Now the next question will come, follow-up question is, what is the main difference between the sleep and wait? So whenever you apply a sleep method, what happens is it does not release the lock on the resource, then still it is going to sleep for the specified amount of the time. But in the case of wait, whenever you apply a wait on a particular thread, then it is going to release the release the lock. That means release the lock on the resource, and then it will waiting for the notify signal from the another threads. So that is the basic difference between the sleep and the wait. Now the next question is, what is meant by thread scheduler and its advantage? So thread scheduler is comes as part of the JVM, which is going to take care of submitting the threads to the CPU. That means thread scheduler will keep on looking for the what are the threads are available, and based on its priority, it will pick up the thread and it is going to submit to the JVM for the execution. So thread scheduler internally uses the two algorithms. One is primitive scheduling, another one is a time slicing. During the primitive scheduling, what happens is the highest priority thread will always submitted the first to the CPU or the JVM. And in the case of time slicing, each thread is going to be executed based on the time slicing whatever we are going to provide it. So that is the basic two algorithms it is going to use, and thread scheduler is the basic responsibilities to submit the available, it will look for the available threads, and based on the priority and time slicing it is going to submit the request to the same JVM for the execution. Okay, so the next question is, can we start the thread already started thread again? Now let us consider I have created a thread T1 equal to new thread. That means my thread class T1 equal to my new my thread class. Now I started a T1 dot start. Again I am trying to invoke T1 dot start. Then what happens? When you try to start already started thread, then it is going to throw the exception illegal thread state exception it will come. Okay, one second, I will explain that one. It is going to throw the exception illegal thread state exception. If you are trying to start the thread which is already running or the already started thread, then this is the exception it is going to throw. So you can't start once a thread is started. You cannot invoke the start method again. Now the next question is, what is a thread group and what is a thread pool? So thread group is basically if you want to segregate a few threads in a one group, And if you want to, you have to differentiate like a few set of the threads is belongs to one particular functionality, and few set of the threads is going to be different functionality. Then using the thread group, you can group multiple threads into a one group, and so that whenever you want to resume or stop or suspend, then using the single command you can go ahead and operate all the threads at a shot. For example, if you see here, I have created a three threads using the my runnable. For example, if you see my previous snippet of the code, how I can create a thread using the my runnable. For example, like that, I have created a runnable class, and using the my runnable, I can create a three threads, thread objects. So here, what I have done is same thing. So I created a three runnable objects, and then I'm going to create a three threads using the thread group. For example, if I say thread group, first I need to create as a thread group is equal to new thread group. You can pass a some name, then you can segregating these three threads are belonging to a thread group. So now what happens is, if you want to suspend or the stop or resume, then using thread group dot stop that group dot resume or the stop or resume, then what happens is all the thread at one shot you can do it. So that is the main advantage of the thread group. So thread group, basically, if you want to categorize a few set of threads as a one group, and you can operate a single command to perform operation on these multiple threads, then you can go with the thread group. And the next one is the thread pool. So now what happens, what is meant by thread pool is, you can now what happens is, if you want to create a each thread, then what happens is, creating a thread is going to be a costlier operation because it needs to utilize a lot of resources. So every time we want to create a one thread, it is going to take a lot of resources, and it will create it, and again you want to destroy again. This is a lot of tedious process. So now what you can do is, whenever you start your application, you can specify that I want to create a 10 threads by default when application starts. Then I am going to, how many threads I want to use it, I am going to use out of those 10 threads only. For example, you have created a 10 threads, but your tasks are 20. Then what happens is, once you create a thread pool, first it will execute the 10 threads. Once it is completed, then again it will pick up the next 10 threads. So that is the basic concept behind the thread pool. So by using the executor service, you can create a threads as a fixed component whenever your application is going to be start. This is the syntax. For example, executor service executor is equal to executor dot new fixed thread pool of 10. That means this will create a 10 threads whenever you start your application, and using this executor, you can submit the request to the, you can use the, for example, executor dot execute, and you can pass the whatever the runnable object is there, then you can pass to this, then it will execute it. Once the operation is completed, again the thread will be coming into the pool for the next to serve the next request. So the main advantage is, it will have the better performance, and also it will have the better performance. So that is the basic principle behind creating a thread pool. Okay. So next one is, what is meant by daemon thread. Daemon thread is a service provider for the user defined threads. That means it does not have really functionality, but it is going to be like a helper threads for the user defined threads. So that is meant by daemon thread. For example, one example is the garbage collector is we call as a daemon thread. So it is going to be lowest priority, and it is going to support the user defined threads. But by default, it does not have any importance if there is no user threads are trying to run. If user threads are not running on the application, then there is no value for the daemon threads. So if you want to set any type of if you want to set any thread as a daemon thread, which is going to be lower priority, and it is going to help you to helping the user threads, then you can mark that thread as a daemon thread. You can mark a thread as a daemon by using the thread dot star set daemon as a true, then automatically that will be considered as a daemon thread. The next question is, why wait, notify all methods are part of the object are not part of the thread class? Because now if you see the wait, notify and notify all are always present in the superclass called as a object, but not as the thread class. Now this is to just understanding about the design, because interviewer want to know whether you are really understand about the design of the object class or the Java. So now let us consider wait, notify, notify all. So these are basically working with respect to the locking. Now whenever you take a lock on the particular object, you are always taking the lock on the object, not on the thread. Thread class is purely to create a threads, but actually if you see, when you are acquiring the lock, you are acquiring the lock on the object or the resources, not on the threads. That is the reason the wait or the notify all is always attached to the object, not to the thread. Now waitify, what happens is it is going to release the lock on the object, not on the thread. Notify also, once notify, the thread will notify, it will say that yes, you have an option availability to acquire a lock on the object, go ahead and execute. So that is the reason wait, notify are part of the object class, not rather than with the thread class. Always make sure that we are acquiring the locks on the objects or the resources, not on the threads. So that is the reason the notify all or the methods are defined in the object class. Now, can we invoke the run method instead of start method? Now, what it means is I'm going to explain. If you see the my previous snippet, how we created a thread. Here, this is how we created a thread using the my run. Now, what we can do is we can create an object for the my runnable, and I can directly call the my runnable dot run method. But usually what we will do is we will create a threads for using this runnable object, and then we will say that thread1 dot start. For example, if you see here thread1 dot start, what if I can directly call thread1 dot run? What happens? So whenever you run the run method directly instead of start, then what happens is it will consider as a one process, not as a thread. That means whenever you create a threads, what you can see is there is a context switch between the threads, it is going to happen. But in the case of when you directly call the run method, it will consider as a normal method, and it will not create a thread. Instead of that, it will consider as a only single thread it is trying to execute. So how many times you are going to call that run method, one by one method, one by one thread, it is going to start complete, but it will you can't see the context switch between the threads. So that is what the basic difference. Then what is the interrupted exception? What is illegal state exception? So this is the one of the exceptions, most frequently seen exception while you are working with the multi-threading. Basically, whenever you apply like a sleep method, you apply a sleep method, and you can pass the predefined milliseconds it want to sleep. In the meantime, some other thread is trying to interrupt it using the interrupted method. We have a interrupted method. If you some thread is trying to interrupt, then what happens is it is going to throw the interrupted exception. At the same time, wait method is also same. In the wait method, what it will do is it is going to wait for the other thread to notify it. In the meantime, some other thread is actually interrupted that waiting method waiting thread, then that also it is going to throw the interrupted exception. Now next one is illegal state of exception will occurs when you are trying to start a thread which is already executing, then it is going to throw the illegal thread state exception. Then next one is what is meant by synchronization and advantages of it. Synchronization is a mechanism or the concept which is going to restrict the shared resources by allowing only one thread at a time. During the multi-threading always use the common shared resources. So synchronization is a mechanism which is going to restrict the shared resources by allowing only one thread at a time. If you don't apply the synchronization on the shared resources, there are two problems. One is memory inconsistency is there, and second one is thread interference. So these are the two problems arises while working with the multi-threading. So you have to apply synchronization on the shared resources to make sure that to avoid these two problems. Okay, so synchronization is a mechanism which is going to restrict the access on the shared resources by allowing only one thread at a time. Now, what is the use of synchronization block method and the static synchronization? So basically, in order to apply the synchronization, the Java providing a three different type of implementation. One is a synchronization block. So synchronization block is synchronized. You can pass here the instead of this you can pass as a resources where it is the resource is nothing but the shared resources. Now what happens is whenever thread is executing, whenever it comes to the synchronized, what happens is it will take the lock on the resource and it will go and execute this one, so that by the time while executing this block, if any other thread comes, then it has to wait until the current thread is going to be executed. So this synchronization by default use the intrinsic locks. That means whenever you want to execute anything on the synchronized block or the method or the static synchronization, it has to acquire the lock on the resource and then it will go execute it. Once it completes, it is going to release the lock or unlock. That is what the concept is. So by using this locking mechanism, by using the synchronization, what you are going to do is you are going to make sure that only one thread at a time it is going to access the shared resources. That is meant by synchronization block. So synchronization block has a shorter duration because now you have 100 lines of the code in your method or the program. Then where you want to apply the synchronization or you are manipulating the shared resources, out of 100 you are manipulating within the 2 lines. Then instead of putting the synchronization completely for the method, you can go ahead and apply for the only those few lines of the code where you require the synchronization using this synchronization block. So synchronization block is going to be a shorter duration of acquiring the lock and releasing the lock. And once a thread is acquired the lock, no other thread cannot enter into this critical section. We call as a critical section. Okay, that is the synchronization block. Now synchronization method. Synchronization method having the higher visibility than the synchronization block. So you can apply the synchronization method by applying the keyword synchronized to the method. Now, when you apply the synchronized keyword to the method, what happens is this method is called as a synchronized method, and whenever multiple threads are trying to access this method, as this is you have marked as a synchronized method, only one thread at a time it will come inside of this method. That means again, whenever it invokes this method, it has to acquire the lock on the method or the method, and it will execute it. Once its execution completes, it will release the lock. Then second thread will come, take the lock, execute it, and then release the lock. So this is the process it is going to happen when we apply the synchronized method. The next concept is static synchronization. So whenever you apply the static synchronization on the method, what happens is this method will be the lock will be acquired on the class, not on the object. So static synchronization means it is going to acquire the lock on the class rather than the object. So now what happens, how many threads are trying to access this method, then only one thread at a time it can access the at the class object. Okay, so static synchronization is always going to be at the class level, method is going to be at the object level, and the block is going to be based on the particular resource or the object, or even you can apply at the class. What is meant by deadlock? So deadlock occurs one, when one thread is waiting for the lock. Okay, let us consider this way. So what is meant by deadlock? So deadlock situation will occur like this. There is a thread 1 and thread 2 are there. Now thread 1 is waiting for taken lock which is acquired by the thread 2, and thread 2 is waiting for the lock which is acquired by the thread 1. Now both thread 1 and thread 2 are keep on waiting to release the lock each other. Now this situation is called as a deadlock. If you don't implement the synchronization blocks or the synchronization block or the method concept properly, then it leads to the concept of deadlock. So where one thread is waiting for the lock on the another resource and another thread is waiting for the lock on the another first resource, and keep on waiting for each other. So this situation is called as a deadlock. Okay, so how to avoid the deadlocks? So always make sure that in which way you are trying to acquire the locks, the same way you need to release the locks. So that is what meant by the deadlock. How to detect the deadlocks? So there are a lot of tools are available today to verify whether a deadlock is happened on the application or not. one of the tool is the JConsole is the one of the simplest example to identify whether there is any deadlock happening in your program or not. The next one is what is the use of the volatile keyword in the Java. So volatile keyword is applied for the variable member variables. That is, whenever you apply properties in a class, then you can specify the volatile keyword for that for the member variable or the property. Then what happens is in during the multi-threading environment, when multiple threads are trying to access the particular variable, then volatile keyword is always make sure that it will try to get the latest value whatever it is available on the memory. That means it will first it will go check and see whether if the value is changed or not. If changed, then always it will go and fetch the latest value. So in order to make the consistency during the multi-threading environment for the variables, we are going to use the volatile keyword. Whenever you apply a volatile keyword for a particular member variable, then it will go and check, then get the value. If it is modified, that means it will always will get the latest value to make the consistency of the variables. And then what are the atomic classes and its advantages? Atomic classes are the classes which is almost equivalent to the volatile. So each class like a integer or the float or the float or the boolean, for that each there is a corresponding atomic classes are there. Then what these atomic classes are going to say is like before happen relationship it is there. So happen before or before happens. So before actually it will go and get the whenever you invoke getting the value, first it will go and check whether these days modified or not. Then it is going to return the latest value. So during the multi-threading environment, if you want to make a consistency across the variables or the whatever the values you are defining, when multiple threads are trying to access these atomic classes or the volatile keyword is going to make sure that you are always getting the latest value from the whatever it is updated in the memory. Okay, what is meant by lock? So lock is an interface which is it is provided in the concurrency packages. So the one way you can restrict the shared resources access by using the synchronization. Alternatively, the latest releases of the Java they provided with the locking concept. So locking is also the same concept of the synchronization, but it has in a more advanced way. Like in the case of locking, what happens is before you take a action on any resources, you have to acquire the lock and then you have to release it. That is the concept of the locking. It also provides flexibilities like in the case of synchronization, what happens is a lowest priority thread it may not get always the chance to execute the CPU. But in the case of locking, you have an extra flexibilities like you can immediately take a lock on the particular resources. And also, if you want to execute like a highest priority thread, always needs to execute the properly. And also, if you want to execute like a longest waiting queue should get the highest priority to execute into the CPU. Then those type of capabilities it is handled in the locking. Then what is the difference between the synchronization and the locking? Synchronization is basically you can apply at the block level or the method level or the static synchronization. In the case of locking, it has the advanced features than synchronization where you can try a lock immediately on the resource, or you have an reentrant lock is one of the implementation of the lock where you can specify the fairness policy, and also you can specify that whatever the thread which is waiting for the long run you can get as a highest priority to get to key executed in order to eliminate the starvation process. So those are the few additional functionality which is going to be available in the locking. Okay, so hope you are clear with all these questions, and if you have any questions please comment on my YouTube video. Please do subscribe to my YouTube channel to get more technical videos. Thanks for watching.